I would say he's really grasped the challenges in Berlin in 4 short days, wouldn't you? Did I hear that correctly? 4 days, yeah. We expect a lot more in the next 4. I can tell you that. It's really amazing, though, to see, the global cities and the focus that's really been given to the challenges of sustainability and energy conservation and carbon reduction. And I think you can see a theme from these presentations that around the world, political leaders and professionals are really taking this extremely seriously, and that we are going to make progress. But I liked what you said quite at the end of your remarks when you said, we attend a lot of conferences and we kind of envision and we talk about things. It's really time to act, isn't it? We really need to kind of move forward. And again, I think the opportunity to do things effectively is now, and we must do things now. In this next segment of this afternoon's program, I'm going to call a panel together to talk about the issue of continuous improvement. And what we're going to really be talking about now is how we really attack, and I think that's the right word for it, our existing building stock to see how we can really make those buildings much more efficient and use less energy. So I'm going to call to the stage 3 individuals who have a great deal of experience in kind of engineering and product design to help us in this discussion about how we can really retrofit, I would say, renovate our buildings to be more energy efficient. First is Mr. Bob Dixon, who's the Senior Vice President and Global Head of Efficiency and Sustainability from Siemens. Welcome, Bob. Thank you. Thank you. You want to take a seat? Yeah. Second is Dr. Thomas Tang, who's the Director of Corporate Sustainability, Asia, AECOM, UK. Dr. Tang. Okay, we'll call everybody back up. And finally, Dr. Raymond Yau. He's a fellow with ARUP here in Hong Kong. Welcome. Please have a seat. So I think I'd like to really begin by asking you, Mr. Dixon, just about where we are really with the kind of technology to evaluate our existing building stock, and can we really effectively use that technology to kind of monitor effectively energy use in buildings, water use, and other kind of uses in buildings? Because I mean, we've really heard about the desire to really do so. Tell us a little bit about the technology that allows it to happen.
Sure, George. Thank you very much. It's great to be here. I will answer that question in just 1 second, but I think I want to point to an analogy that will indicate why I think the monitoring of energy consumption in buildings becomes so important, how to get it done. I can point to 3 examples: fire detection, smoke detectors, fire protection, sprinklers, elevators, and cars. I've always, for a long time, have had regulatory requirements to report on how they're doing. And why was that done? It's done for the good of, basically people safety. It was, you want your fire alarm systems to work, your fire detection, cars, it was certainly the indoor air. But in the building world, by and large, once a building is built, whether it be to the great LEED standards that are going on right across the street, once that building is built, it's left to the building owners fundamentally to have that responsibility. And we all know over time building performance will decline. And so my adage is, if you can't measure it, you can't manage it. And so I think what needs to happen, first, regulations need to be in place to report on building performance. They do consume 40% of the world's energy, create 21% of the greenhouse gases. It's time that we make that a mandatory. And is the technology there? It absolutely is there. There's a lot of ways to get the reporting into systems to make it effective. There are human sensors. People that run buildings have a lot of information they can put into systems. We can go to the existing building automation systems that are present in most commercial buildings, most government buildings here today. There are new wireless technologies that are being placed into buildings every single day to allow gathering of information, whether it be on specific chillers or boilers or lighting systems that they've never been able to do before, concentrate that and take it back to systems where analytics can be applied that make the turning the information into knowledge, and out of that knowledge becomes power. And let me just give you an example. No commercial advertisement, but we happen to have, yeah, you're welcome. But I know of a company, I do happen to work for them, that by end of business year will have over 70,000 sites in 20 countries, 22 countries, being monitored and evaluated for energy consumption and greenhouse gas reduction strategies. And that's significant to me because it shows that the technology is there to do it. The analytics, think how hard that is for an individual person to do. Weather normalization, operational normalization, different utility footprints for emitting carbons. How does a single building do that? And if you have a very large, wide footprint, how are you going to, if you're a global kind of company, how are you going to do that in 25 different countries? Very difficult to do, but the technology is there. It's surprisingly cost-effective in today's world, and I think if we had a good regulatory emphasis to make that sort of mandatory reporting done, we would be able to take really fundamental step changes in reducing energy consumption because you know where to go to start first.
Thank you, and I'm sure that information that you gain from monitoring those buildings in 22 nations really will be a good case study that can be shared with the public sector, I suppose, and kind of allowing public buildings really all around the world to kind of have now gain that knowledge of system control.
Absolutely. One of the nice things is that you are able to do some building comparison that we've never been able to do before. You know, benchmark hospitals, benchmark office buildings, schools, and public sector buildings, providing comparative data to clients and users. Before it's, how am I doing? Well, it's not only how am I doing, it's, yes, I need to do better, but maybe I have opportunities to do much better. Let me see comparable buildings to benchmark myself against.
Dr. Yau, Arup, of course, is one of the leading, engineering companies in the world. Also, I think they do a little bit of architecture from time to time. I'm very interested in kind of the kind of consideration in your organization of when you're really retrofitting buildings, of the exterior building envelope, and how much of an important role that really plays in the energy performance of buildings today. Would you comment on really that aspect of Arup's focus?
Yes, certainly. In fact, just a few days ago, we have received over 7 Green Building Awards, Hong Kong, including a couple of projects in China on planning scale. And all these place a lot of emphasis on the overall integrated design approach. But we're yet to actually get a similar prize on existing building. And hopefully the China resource building that we are helping as a sustainability consultant would enable us to achieve that particular. But
I think you're setting the mark up high and you've got to deliver now.
Yes,
absolutely.
Because existing buildings is always seen to be a very difficult building stock to address particular energy performances and so on, because you don't have the flexibility to do a lot of changes. But I also echo to this morning's the New York building commissioners on benchmarking energy performances, similar to what you said earlier. We need to understand how buildings perform. And quite often we find where the energies are being consumed will fall onto the envelope and the systems. For existing buildings, quite a lot actually on the system itself, but still a great deal proportion come from the envelope because it has a direct impact on solar load, and it's too much, then you need to open the chillers or reduce the potential of natural cross ventilation and so on. So as an organization, as a design house, we place very much emphasis on the integrated design addressing the envelope design. And also In particular, putting ourselves in the Hong Kong context, over more or less 50% of the energy consumption on existing building stocks are consumed on the high commercial and office buildings. Residential, in the sheer volume, no doubt occupies a great deal of energy consumption, but in terms of energy intensity, it is the commercial and also the retail. So the government, the yet to be enacted, might be forthcoming building energy code is to address the major energy consumer. But hopefully, as the government might have explained that they wish to put an act together on energy efficiency of existing buildings, but see the large stock of existing building stock, then actually understanding the performance and then come up with strategy in tackling it, both in terms of building envelopes and the systems, and understanding how and let the results known to both the developers as well as end users, because behavioral change is going to drive everything. If they know how much is spent on it and they will need to dig deep in the pocket in paying for it, then there's a lot of incentive for them to change their behavior pattern, particularly on existing buildings.
Thank you for that comment, and it does seem to me that a key to our success is going to be changing behavior, and you know that I think if the children get involved, I think it may happen to their parents more quickly than they think. So I like that idea, as I said before. You know, a part of this focus on energy conservation and planning, of course, deals with the overall planning of our communities. And in this part of the world, of course, and in the Middle East, many large architectural and engineering firms are really involved with the design of new large communities. And it seems to me that when one really sets out to design a new community or a new urban center in the Middle East, for example, and I know AECOM is working really all around the world, there's an opportunity for the kind of design of systems and the monitoring of systems really to go beyond the individual building to kind of the neighborhood and kind of the energy that is used on a broader range in an urban environment. Would you care to comment on what your organization is focusing on in these days in terms of the overall kind of energy strategy for design of new urban areas?